Okay, folks, time for that third and final strategy for systems of equations. It's called the substitution strategy. And today I'm going to start teaching it to you. So if you would, make this the last or the next title on your in your math notebook and close it up and concentrate. And here we go. All right. So far, if we take a system of equations like, say, this one, we've learned two ways to solve that. One's called the elimination method, where we either add or subtract the two equations together. This case, subtracting it would be ideal because when I do, y minus y eliminates one of the variables, negative x minus 3x, and 4 minus 0. And once we've eliminated one of the variables, we can find the other one. So let's see, I think that would be 1. Yeah. And then once we know 1, we can put it into one of the original equations, and 3 times 1 is 3, and we got that. So one method we can use is elimination. The other is graphing. I already did that. The first equation's here in blue, second equation's here in red. They meet right there at, looks like 1, 3. And lo and behold, they match. X equals 1, x equals 1, y equals 3, y equals 3. And we're there. There's one other way to do it. So I think I told you a long time ago, there's actually 3 strategies common to finding system of equations solutions. One is graphing, got it. And then the other 2 we call the algebraic strategies, where we end up doing a lot of algebra. We've learned elimination. Going to teach you the third today. It's another algebraic method called substitution. And substitution, one situation where this strategy is useful is when both are in slope-intercept form like this. So let me show you how that works. So we have to have, I'm going to ask you for like a jump in logic here. So what I know is all of this equals y. I also know that all this equals y. So I know 2 things that are equal to y. So what that lets me do, I'm just going to start, let me start with the top equation here. I'm just going to write that down here. And here's why this is called substitution. What I'm going to do with the substitution strategy is I'm going to say, okay, here's a y in this equation, and having both variables in there makes this hard to solve. I know something else that's equal to y, and it's this. And if we think about math in its most fundamental way, an equal sign means this and this have the same value. So what I can do is I can substitute this other thing that equals y instead of it. And I'm literally going to replace y with something equal to it, like that. So again, let me kind of go through that again, because I know that's kind of a complicated idea, and it works either way. I can take this equation, I can say I take the bottom one, and I'm saying, okay, I've got 2 variables in there. If I knew one, I could find the other to find their solution. So I say, okay, here's what I want to tell myself. I can replace y with something else that it's equal to. Y is equal to 3x. Y is also equal to x plus 4. So I can literally substitute and replace y in one of the equations with the other thing that it's equal to in the other. I'm literally substituting this in for y because it's equal to y. Now look what happens when I do that. Now I've only got 1 variable. And when I've only got 1 variable, I can solve for it. I can figure it out. When I have 2, I can't. When I have 1, I can. So this, I can start to figure out what to do. I can add x to both sides. And that'll eliminate that. Now I've got 4 is equal to 4x. And I know x equals 1. So with that substitution method, another way I was able to make one of the variables sort of disappear, and found it. And so now I've got x equals 1. How do I find y to complete my solution? Well, same as with elimination. Once you know one of the variables, you can just go back to your original equation, whichever one looks easier, and you can use x to find y. So now that I know that, I would know that y equals 3 times 1. So y equals 3. And you'll notice that solution matches exactly what we found back here. 1 and 3, 1 and 3. All three methods give the same solution. It's kind of a little slick trick. It's kind of like saying, okay, well, look, if y is equal to that, and y is equal to that, since they both equal y, this and this must be equal to each other as well. Pretty fancy. Let's do one together. So if you will, start by opening your notebook and let's just talk about some context first. So there are 3 ways to find the solution for a system of equations. One strategy is graphical, the other 2 are algebraic. So here's the example we're going to do. We have learned to solve that already with the graphing strategy. We have learned to solve that already with the elimination strategy. Substitution strategy is going to be new today. So in the event that you're not in love with either of the first 2 strategies, got a third one for you. So unpause when you're ready, and I'll show you how to do it. So what we're going to end up doing here, first of all, note, substitution strategy is helpful in situations where both equations are in slope-intercept form, like they are here. Here's the reason why. I'm going to take that first equation, I'm going to kind of write it out. Y is equal to 2x plus 2. That means y and 2x plus 2 equal means they have the same value. So y and 2x plus 2 are equal to each other. Now, y is also equal to x plus 1. So if this is equal to y, I can substitute it in y's place. So literally what we do is we're going to take this x minus 1 and say x minus 1 is the same as y. That's what my equation here says. So I'm going to replace it or substitute this other thing that's equal to y in for it. Now I've got an equation that only has one variable. And when I've only got one variable, I can figure it out. So look what I did. We said y is equal to this. Y is also equal to this, which means those 2 things are equal to each other. They also have the same value because they're both equal to the same thing. I hope that logic makes sense. That's the logic behind the substitution method. I think it's tricky. So once I've got here one variable, you can solve. No problem. Let me add the opposite real quick so I don't end up subtracting. So I've got x's on both sides. I think I'll take 1 away from both sides. If I do, that's eliminated. Equals 1x plus 2. Now I would probably take 2 away from both sides or add negative 2 to both sides and get that. And now I know that x equals negative 3. Not done yet. Don't forget, I also need to know what y equals. And the way I do that, if you want to write it, say find y same as with elimination method. So what I'm going to do now, I'm going to take this. The bottom one looks a bit easier. So now that I know x, I'll use it to find y. So y equals negative 3 minus 1, or plus negative 1, and y equals negative 4. Now I've got a full solution. And that is how it works, or at least how it works when both equations are in slope-intercept form. Future day we'll look into some places where we can use this strategy when it's not in slope-intercept form and see how that goes too. I feel like this is a big leap, guys. I don't think the math is terribly hard, but just this idea of how you get started, I think is tricky. So if it would help to go back and watch this again and hear my explanations one more time, please, please, please do that. I think this is one of the more complicated ideas we learn all year, to be frank. So I hope it made some good sense to you. All right, that's what I've got to say. I will see you tomorrow.